Hello all students. Just before starting the main assignments, we will just switch over to the basics and later on we will do the experiments or the assignments given as per the syllabus. Here we are going to add two numbers, means two hexadecimal numbers and display that result. Now here we are taken two numbers 4b and 21. If we add those two numbers b plus 1, the answer will become c, and 4 plus 2, the answer will become 6. So 6c, that will be our answer. So that is to be displayed. Here you can see the program, that dot model dot stack dot data. Under dot data we have defined the data, and under dot code our code starts with first instruction, that is move ALA, to the last instruction JNZL2. This is the termination of the program and end of the program, and comments to each line is given over here for your reference. So as per discussed in last time in the other basic video, that we will be going to write firstly our program. After that we'll be going to assemble it by using the command asm and our file name. Then we will use t-link command and name of the file, and that t-link will make you executable file, and then my file, by using the file name we will be going to execute the program file. Now to write the program we will use edit myfile.asm, means edit name of the file and .asm. Now we will start writing the program. So to write the program we can use this kind of assembler. You can see after installing TASM 1.4, you can see this kind of icon on the desktop. Just double click on it, you will observe this kind of window that will get opened up. Now by default you are at the location C where TASM folder is located. So I will start writing the program now. Now in order to write the program I will use edit command. So here I am writing the command edit an.asm. Now an is the name of my file, then I will press enter. Okay, now here you can write the program, or I'm having a program which is already written over here. So after writing the program, so it is written already. So after writing the program I will say, I will go to file, save, okay, and exit. Okay, I will come to previous location where I was. Then after this you can observe in your folder where program is there, go to C drive, then TASM 1.4, and in TASM folder. So you will observe different files over there related to TASM, and one more file you can observe, that AN has got created with extension ASM. Okay, this AN file, if you open up in notepad you can observe this kind of program which you have already written there by using TASM. So I will close that window, and here I will now assemble the file. So for that purpose I will write tasm an is the name of the file. Now here there are no any errors you can see. So error message none, no warning. Okay, if there is error message, the line number is shown in that case. Now you can see there was a single an file previously. Now an.obj has got created. So this tasm will create object file. After that I will type t-link and an, t-link an. So just because of that we will see live in this portion there are two files with the name an. Okay, now one another file will get created after this, that I will show you. If I press enter, then you can see map and object files, sorry, map and executable, an executable and an map both has got created. An, that is application, an.map, it is a map file. Then I will run the executable file. So executable file is created, an, so I will press an and enter. Here you can observe the output 6c. This is your output. Now we will analyze the program. Okay, now we will start the programming concept of the previous program that we have gone through already. So in that program there were sentences. Those are called as assembly level sentences. Now here we will see the flow of the program, how the program logic is, that we will analyze. So initially we will take two numbers 48 and 21. This is hard coded programming. It means that we are not going to take any number from the user. We have already kept two numbers inside our program. Now we will firstly take those numbers in the registers. Now there is one instruction, that is add accumulator AX or AL. You can take AL, and then you can write, or you can take any register. Let's suppose BL is one another register. Here for addition you will require accumulator. Okay, so for that we have taken one number in accumulator, that is A in accumulator. That's why 48 will be there in accumulator. Number B, second number, that is 21, will enter in BL register. After that we will execute that instruction, that is add AL BL. So content of AL will get added with the BL and the result will get stored into AL. Here we will set the counter. This is the CX register. Okay, out of which CH contains 2 and CL contains 4. So here in CX register, this is whole CX register which is of 16 bit, out of which this CL lower 8 bit contains 4. 4 means 0 0 0 0 0 1 0 0. So this is 4 0 4, and the higher byte, that is higher 8 bit CH, it will contain 2, that is 0 0 0 0, which stands for 0, and 0010, it stands for 2. So CH is holding 2, CL is holding 04. So those are the contents of CX register. Later on we will discuss why we have taken CH equal to 2, CL equal to 4. Okay, then here there is a problem. The problem is we are considering those numbers 4B and 21. Those numbers are hexadecimal number. If we add those two number, hexadecimal number 4B plus 21, answer will be 6C. But if you try to print 6C onto the screen directly, 6C will not get printed. Here our screen, the monitor, it recognizes only ASCII value, or it prints only the ASCII value. So if you try to print 6C, so 6C is here. If you try to print 6C, I will make it zoom. Okay, if you try to print 6C, here L will get printed. Okay, L will get printed. So our result will not get printed at all. Something else will get printed. So what we will do here is we will convert our result, that is 6C, into its ASCII value. Okay, the ASCII value for 6C, that we will have to calculate. So here firstly we will print 6. The ASCII value of 6 is, the ASCII value for 6 is, that we will have to find. Okay, this is the ASCII value. Okay, ASCII and hex, ASCII and hex, that we will see now. The ASCII value for 6 is 36. So here we will have to print 36 first. Okay, and then we will have for 6, it's 36. For C, for C, ABC. Okay, here is C. For ASCII value C, we will have to get hex value as 43. Okay, so here in order to print C, we will have to send 43 onto the screen. The moment when we print 36 and 43, 6C will get printed onto the screen. Okay, so for that logic, what we have done is we have taken the content of AL contains 6C, that is the result, in BH register or BL register. Okay, so after this we will extract 6. We have extracted 6 from here. Okay, and we have added 30 into it, so that we will get 36. Okay, and later on during second iteration we are expected to print C. So for that purpose we have added 37 into it. Okay, and we have displayed that number. So this is the flowchart. Now we will see, or we will analyze each and every step. Later on we will try to understand the flowchart and algorithm. So firstly, the first step is to take 43 into AL register. Okay, so we have taken 43 into AL register and 21 into BL register. Then here add the content of AL and BL. So here we have added the content of AL and BL. AL is equal to AL plus BL. So content of AL has become 6C. Okay, and after this, now we are expected to extract 6, and later on we are expected to extract C. Okay, so in order to extract only 6, now what we have done is we have taken the copy of AL into BH register. So content of BH will be 6CH. Okay, the content of BH register will be 6CH, and here you can see the content of BH will be 60110, and for 6 it is 1100. Later on, now there are two iterations because we are expected to print the value of two numbers. One is 6, another is C. So this is the first step, and we will be going to perform same operation on C over here. Okay. So we will, in order to extract 6, we will firstly hide C from it. Okay. So what we have to do over here is, in fourth step, we have left shifted the content of BH register by 4 bits. Okay, so here what will happen, 0 will get shifted 4 bits, 1, 2, 3, 4. Later on this 0 will get shifted 4 bits over here. This one, 1, 2, 3, 4, and this one, 1, 2, 3, 4. It means that this 1100, that is C, will come at left, and this 6 will get rotated and will appear over here. It means that 6C will get swapped with C6. Okay, so when you rotate, or when you shift the bits or rotate the bits of BH by 4, when you rotate it, you will get the content like this. So previously it was 0110, 1100, now it is 1100, 0110. So these numbers, you can see those has got swapped. Now in order to hide the alphabet C, we have ORed it with 0f. So for that purpose we have taken the content of BH, that is C6, into BL. We have taken the content of BH C6 into BL register, and then we have ANDed the content of DL with 0f. So you know anything ANDed with 0 is 0. Okay, so here previously we were having 4B in AL, 21 in BL. Addition of both is 6C. It was here. Okay, and after swapping we have got in BH register C6. Okay, we have taken that copy into DL register. Now we have C6 over here. We have C6 in DL register. Now we will OR the content of DL, that is C6, with 0f. So add when you add 0110 with 1111, anything ANDed with 1 is that number only. So you will get 0110 as it is, as the result. Whereas anything ANDed with 0 is 0. So you will get 0000 at DL. Okay, so DL now contains 06. So in this way we have extracted 6 from our result, that is 6C. Now we will compare that 6 with some condition. Okay, Now here you just try to observe that whenever I add 30 into 0, I will get result 30. If I try to print 30, 0 will get printed. In the same way, if I add 30 into hexadecimal number, that is 606, 6 plus 30, I will get 36. If I try to print this 36, 6 will get printed onto my screen. Okay, so this is the logic that we will be going to perform. So here I will check the number is less than or equal to 9 or not. Okay, so here we have extracted the first digit, compare it with 9. If the digit, that is number 6, is less than or equal to 9, then add 30. Otherwise add 37 to get the number, okay, to get the ASCII number and display that digit, that is ASCII digit. So in this way we have compared 6C, the content of DL, whether it is less than or equal to 9. If they are less than 9, then we have added 30 into 6, we have got 36. Now the content of DL is 36. We will display that 36 so that 6 will get printed onto the screen. And we will repeat the same thing for second digit. Okay. Now the content of BH over here, let's shift it by 4 bit, it was C6, out of which we have extracted 6 already. Now our job is to extract C from C6. Okay, the latest content of BH is C6. Now we will rotate the content of BH register by 4 bit. So rotation means, shifting means just to shift towards left. Rotation means here higher nibble will come at lower nibble and lower nibble will go at the place of higher nibble. So the number 6C will become C6. Okay, so the previous content it was C6, now it will become 6C, sorry, 6C. Okay, so 6C can be written as 0110 1100. Okay, we will take the content, or we will copy the content of BH into DL register. Now the content of DL register will be 6C, and after this we will add the content of DL with 0F. Okay, we will add the content of DL with 0F. So anything ended with 0 will be 0, so 6 will be 0, and anything ended with F is that number only, so C ended with F will be C. So DL is holding 0C into it. So 0C means here 0000, C means 1100. Now we will compare that 0C with 9, whether it is greater than or less than 9. Now if the number is greater than 9, now C is the number which is greater than 9. Okay, so if that number is greater than 9, then we'll be going to add 37 into it to get ASCII number. Now how do we know that we should add 37 into it? So C, how to print C? Here you can see the ASCII C value. Okay, ASCII C value has hex value which is equal to 43. So if you, now this is C in hexadecimal. Okay, so if you try to add 37 into C, you can use calculator for that, but you will have to take care that put the mode of calculator in hexadecimal, not in decimal. So after this, in calculator you try to add C plus 37. Okay, C plus 37, you will get the answer which is 43. Now you try to print this 43 onto the screen. Okay, so here if DL is less than or equal to 9, no, it is not less than or equal to 9. So add 37 into the content of DL. So 0C plus 37 is equal to 43. Now DL is holding 43. Now if you try to print content of DL, that is 43, onto the screen, you will see C, the alphabet C onto the screen. So in this way, firstly we have printed 6, the ASCII value of 6, and then we have printed C by printing the ASCII value of C. Now we will try to understand the remaining flowchart. Okay, here we have taken the copy of AL, that is 6C result, into BH register. Okay, after that we have checked whether CH content those are greater than 0 or not. Is just because the content of CH is 2. Okay, CH is equal to 2 because we are doing the same operation two times. Okay, we are doing the same operation two times, so we will require a loop to execute first and second two times. So that's why CH is taking care of that loop. And we have kept 04 in CL. CH contains 02, CL contains 04. So in order to rotate, you can see at this place at your left, BH left shifted by 4 bits. So in order to rotate the content of BH register by 4, CL is holding that value which is equal to 4. So content of BH will get left shifted by 4 bits or left rotated by 4 bits. Then we have taken the copy of BH into DL register and we have ANDed the content of DL with 0F. Okay, so in this way we have got 6. We have checked whether 6 is less than 9 or not. Content of DL is less than 9 means 6 is less than 9. Yes, come down at this place. Add the content of DL with 30 means 6 plus 30, it will become 36. Display that number. Okay, display that number. CH minus minus. So previously see it, the value of CH was 2, now it is 1. So it will go up. 1 is greater than 0, S come down. Or rotate the content of register BH by 4 bits. So here the content will become 6C. Then take the copy of 6C in DL register and the content of DL register with 0F. Here you will get only C. Out of 6C, you will get only C. Now check whether C is less than or equal to 9. No, C is not less than or equal to 9. So come down. Come down. Then add the content of DL with 7 first and then add the content of DL with 30. So here basically you are firstly adding 7 and then 30. It means that you are adding 37 in the content of DL. DL is holding C. So C is getting added with 37 in this way. Okay. So C plus 37 you will get 43 and then display that number which is 43 onto the screen. CH minus minus. So CH it was 1, now it has become 0. Check whether 0 is greater than 0. No, 0 is not greater than 0. 0 is equal to 0 basically. So as 0 is not greater than 0, come down and stop. So this is how our program is getting executed. Now we will try to understand the program. Here dot model small. This is the program size that we are defining over here. After that dot stack 100h. It means that we are defining the stack size. Under the assembly directive dot data we are writing a db 44bh and b db 21h. So here we are again using one more assembly directive, that is db. db means define byte. So here we are assigning a with 1 byte value which is 4b. 4b, if you try to convert that 4b into binary, you will get this 01001011. This is of 8 bit. This is 8 bit value. So that's why 8 bit means 1 byte. So define byte. It is 4b. In the same way, we are defining byte value for b and that byte value is 21. Here we have already studied move ax comma at the rate data move ds ax. So here ds is holding the starting location of the data segment. The start at the start location you have for BH. After that, we have moved the content of A into AL, B into BL. So that's why AL register is holding full B, and 21 will get moved into BL register. Then add AL BL, add both AL and BL, and after this, so add BL AL. Okay, so here you can see content of AL will get added with BL, and the result will get stored in AL itself. So result is there in AL. So AL is holding the result value, which is 6C. After that, we have moved 02 into CH and 04 into CL. So move CH 02H, move CL 04H. Then after this, take the value of AL register into BH. The content of AL will get moved into BH. So move AL into BH. So that's why we written MOV BH comma AL. After this, ROL BH comma CL. Okay. So rotate the content of BH CL times. Means rotate the content of BH, CL is holding 4. So rotate the content of register BH for 4 times. So in this way, 6C will become C6. After this, move BH into DL, take the copy of BH into DL and the content of DL with 0F, so that 6 will get hidden. So here, take the copy of BH into DL, that's why move DL comma BH, and after this A and D, now this is the command, A and D is the instruction. Okay, and the content of DL with 0FH. Okay, so that only LSB will be visible, means 6 will be visible. Then write CMP. CMP is one more instruction. Compare the content of DL with 09. Here we have done it. Compare the content of DL with 09. So comparison instruction, basically at the background it will do subtraction. So the subtraction will create negative, positive or 0 result. So as per that, you will come to know that both the operand value is equal, or one of them is greater or another one is greater. So on the basis of that, we will be going to use one more instruction, that is JBE. Jump if below or equal. If if the value of DL register is less than 9, so jump if below or equal. The value of DL is less than 9 means it is below 9. So jump where? At label L4. So label L4 we have written at label L4, add the content of DL with 30. It means that when DL is less than 9, go to label L4, okay, and add the content of DL with 30. So in this way we have added the content of DL with 30 and display the number. For displaying the number, we have this interrupt int21h. In that, we have function number 2. This function number 2 will display the character which is available in DL register. So we will write move AH02. 02 is hexadecimal number. Move AH02 int21h. So whenever those two lines get executed, the function number 2 will display the character which is available there in DL register. So DL is holding 36 into it, because 6 plus 30 it is 36. Okay, so 36 will get displayed. So actually when you display 36, that is the hexadecimal. The ASCII equivalent of that hexadecimal means 6 will get printed onto the screen. Now we are left up with C, because our answer is 6C. Then decrement the value of CH. If CH is not 0, then execute this BH is left shifted or left rotated by 4 bit. So jump if not 0. CH was 2. Now if you execute decrement CH, now the value of CH will get decremented by 1, and it is CH, it was previously 2, now it will become 1. Now jump if not 0 to L2. Jump if not 0. CH is 0, no, then jump to L2. So under that L2 label, we have written ROL BHCI, means this one. So ROL rotate left the content of BH for CL times. Okay. So previously it was C6. Now after rotation, the content of BH is 6C. Okay. The content is now 6C and the content of DL with 0F. So what will happen over here is after ANDing the content of DL will be 0C. Okay. After ANDing the content will be 0C. Compare DL with 09. So here basically we are comparing DL, that is C, that is 0C, with 9. Jump if below or equal to L4. Now C is not below 9, means C is not less than 9. Okay, so this instruction result will be false. So it will not jump to L4, it will jump to next instruction, which is add DL07, and after that there is one more instruction, add DL30. So in this way 07 and 30, 07 is hexadecimal number. You can write H over here, or you don't want to write, then you can. So 07 and 30 means 37 will get added with the content of DL. So DL it was C. Now after adding 37 into it, it will become 43. So here move AH02, display the number. So this will display the number 43. When 43 gets displayed, actually C will get printed onto the screen. So here C will get printed onto the screen. Decrement CH. CH is, it was 1, now it will become 0. Jump if not 0, but CH is 0. So this instruction will be false. It will not jump to L2, it will come down. Move AH4CH INT21H. So 4C is the function under this INT21H listing. When you write move H4CH INT21H, it will terminate the program, and this is formal end of the code. So in this way, the code is getting executed and 6C will get printed onto the screen. So this is the basic program. The same program will get repeated again and again, means this particular module of displaying the two-digit number will get repeated again and again in upcoming program. So in that upcoming program, I will skip this logic. To understand the upcoming program, you will have to be sure that you are well prepared with this logic. Okay, so we will stop over here and we will later on start our assignment number 1 after this. Thank you.